Okay, so on your notes is a definition of a sequence. It's an ordered list of numbers. We're talking about a numeric sequence. 4, 5, 6, 7, dot, dot, dot is an example. Of course, it goes 8, 9, 10, 11, 12. They don't have to be consecutive numbers. This next sequence, 3, 6, 9, 12. These are multiples of 3. The next three terms in this sequence would be, of course, 15, 18, 21. Sometimes you'll see a sequence just written like this one is. Sometimes you'll see it in a table. The term number, I really don't like that. Oh, that's right. Okay, the term number n, this really just means the position. The position in the sequence. This is the first number in the sequence, second number, third number. So when you see a sequence without these position numbers, just know that n equals 1, 2, 3, 4. It's just like with the SpongeBob characters. We identified that Squidward was the first picture in the sequence, SpongeBob was the second. You need this n number, this position number, because we're going to write a rule for the sequence based on the number's position in the sequence. So we'll mostly be looking at them in tables, but just know that you could also just have them as a list. The fifth position in the sequence would be number 15, the value 15, and then 18, and then 21. And then if you tried this ahead of time and you filled in this n as 24, it's not 24 because this is an 8. Now we've got an algebraic position in the sequence. So for any number n in the sequence, we need a rule. Like, how would you find the term for any number n? A lot of times students will say, they'll see this plus 3 happening. The value in the sequence increases by 3 each time. And this arrow is important because if I went the other way, of course, it would be minus 3 or plus and negative 3. But when they see that plus 3, plus 3, plus 3, they think, I'm writing this outside of the box because this is the wrong answer. N plus 3 is not the rule for this sequence, because when n equals 1, right here n equals 1, if n equals 1, then when I substitute that value into n, 1 plus 3, I get 4. But when n equals 1, I don't get 4, I get 3 in my sequence. So when you see this plus 3, plus 3, plus 3, it doesn't mean you add 3 to n, it means you multiply n by 3. So the rule for this sequence would just be 3n. And if I try that rule, when n equals 1, 3 multiplied by 1 is 3. If I tried it for n equals 6, and the rule is 3n, 3 multiplied by 6 is 18. And so we see that the rule gives us the value for n at any position in the sequence. Also, if you think about what multiplication actually is, plus 3 plus 3 plus 3, if I had 3 plus 3 plus 3 plus 3, wouldn't that just be 4 times 3? And so it's just repeated addition is multiplication. And so that shows you how to write a rule for a pretty simple sequence.